Hi. I think you're muted. At the bottom, there should be a microphone that you can click on. You see, it shows me that your mic is muted. So if you see at the bottom, there's like icons. No? It shows as being unmuted. Okay, I'm going to try leaving and coming back in case it's on my end. Hello. It still shows you as muted on my end. I'm not sure why. All right, I don't know. Okay, so that. I see your face, but you're frozen now for me. You weren't frozen before. So maybe it's on my end, although this is a first. And you're all still, I'm not sure. Could you try, try saying something now? I clicked on mute on you, but I don't know if it did anything. Hello, hello. Okay, my audio is working.
Hi, I just rejoined the session. Did that work? Yeah, that's great.
It's working.
So that was
Wonderful.
At my end, but leaving and coming back fixed it.
Yeah, I don't know. The old turn it off and turn it on again. So welcome. It's a pleasure to meet you. I'm Vanessa. I'm the events chair at SEDS-Canada, and I'm really excited for your talk. My passion is space robotics, so I'm very interested in it. And I just wanted to check with you, how do you say your name? Just so I don't mispronounce your name. Okay, Jamil. And do you want me to use like Dr. Jamil Shariff? Is it Shariff or Shariff?
Yeah, you don't have to say doctor except in the intro, I guess.
Okay. Cool. So yeah, I have a short intro based on your bio you sent us, and then I'll throw it to you. I'll disappear. And do you want to handle Q&A yourself, or I can come back and feed you questions from the chat?
Sure, if you want to come back and facilitate, that might be helpful. Do we want to test screen sharing right now?
Yeah, let's do it.
the controls are a little clunky. Can you still hear me?
Yep, I can hear you.
It's not permitting me to share right now for some reason.
Yeah, I also see that. Okay, I'm going to go into the back end and see if I can change that setting real quick. I don't know why that is, but I'm on it. Sessions. Okay, I'm going to call in someone to help too.
Sure, no problem.
I'm looking for something to toggle, but not seeing it yet. But there must be.
Yeah, so when I hover
something.
over the icon with a monitor on it, I get one of those, like, forbidden signs,
Yeah.
not permitted, like a circle with a diagonal slash through it. So
yeah, usually that's not how, like, usually it's just normal. So this is the first time that's happened to me. But we'll figure it out. Let me go people. Yeah, I see you're as a participant and trying to see if I can upgrade you to a speaker. Yep, you are a speaker. Okay, you're already coded as a speaker. I'm not sure if only 2 people are allowed. Oh, maybe that's it. Okay, I'm going to check. Thanks, Shamira.
oh, so the other session's still on, so I can't share.
No, it might be that there's a limit to people on stage and it thinks that your screen share is a person. All right, try it now. Does it work? Okay, it will let me screen share. So all I did was refresh the page and came back. So I think that's it. It should work now.
So when you were gone, I was able to screen share, but now that you're back, I can't.
Okay, I'll introduce yourself. I'll leave, and then you'll be able to screen share.
Okay, sounds good.
All right. Thanks for being patient, everybody. If you're here, welcome. I'm going to go right into it with Dr. Jamil Shariff. We just had a few technical difficulties with screen sharing, but we're all set now. I'm going to
We give it a minute or two.
Wait until 11:30, and then we'll kick it off. Yeah.
Okay, just want to make sure my audio is still working.
Yep, you're all good.
We're
just going to wait till half past, then we're going to jump right into it. Welcome, everybody. Really excited to have you. All right, let's get started. So, Dr. Jamil Shariff is an astrophysicist currently working on robotic hardware for space exploration at MDA. He completed postdocs at the Canadian Institute for Theoretical Astrophysics, specializing in the cosmic microwave background, and at Case Western Reserve University, working on polarization experiments. He completed his PhD previously in astrophysics at U of T and worked on 2 balloon-borne telescopes, Blastpole and Spider. For the Spider launch, he lived and worked at McMurdo Station in Antarctica for 6 months. Please give a warm welcome to Dr. Jamil Shariff.
Okay, thanks very much, Vanessa. I'm just going to try sharing my talk. And give me a thumbs up if you can see that. Perfect. So first of all, thank you all for joining my session today. It's a real pleasure to be able to participate in Ascension 2022. And I really want to thank all the organizers from SEDS, especially Ishan, who coordinated my induction as a speaker. So it's really great to have the opportunity to be here today and tell my story. So what I thought I would start with is a little bit of background. So not just background about me, but also background radiation from the beginning of the universe. You see, I am an astrophysicist, and I completed, as Vanessa mentioned, I completed a PhD in astronomy and astrophysics at the University of Toronto back in 2015. And prior to that, I did my bachelor's degree in engineering physics at UBC. But during my PhD thesis, I was part of this international team of 20 or 30 researchers from 5 or 6 different universities. And we actually designed, integrated, and tested a set of state-of-the-art telescopes that together constituted this experiment that you're seeing here called SPIDER. And we traveled to Antarctica and assembled and launched SPIDER on a high-altitude helium balloon nearly into space, above 99% of the air mass, actually above 99.9% of the air mass. So the idea was that SPIDER would have an unobstructed view of what you're seeing there on the right, which is this glow left over from the heat of the Big Bang. It's called the cosmic microwave background radiation, or the CMB. And this is the oldest light that we can see. It's coming at us from all directions, from the farthest distances that we can see out to. And SPIDER's goal, our aim with SPIDER, was to use these observations of the CMB to test some of our theories of what happened in the very first moments of the universe, a tiny fraction of a second after the Big Bang. So in order to do that, however, we had to build this completely autonomous, self-contained experiment. And in particular, at the University of Toronto, we specialized in building the Gondola, a fully autonomous, pointable platform with all the actuators and control electronics and software and sensors and thermal control systems that would enable this experiment to operate in a near space environment. So after my PhD and my postdoc, when I was looking at what I wanted to do next, it was kind of this experience with end-to-end systems integration for a spaceborne payload that made the connection to MDA and to robotics and automation. So I love talking about my experiences with SPIDER and talking about Antarctica. So if any of you who are on this talk today are really interested in that topic and in astrophysics and cosmology, I'm happy to also answer questions about that after the talk. Unfortunately, Professor Keith Vanderlind, who is himself a cosmologist, his session is running concurrently to mine. So I was going to direct you to him, but I don't want to lose any viewers. So please stick around, because today what I'd like to talk about is more along the lines of what I've been working on since I joined the technical staff at MDA, since I moved from academia into the private sector. So that transition happened in January of 2019. And since joining MDA, I'm really privileged and excited to have been part of a new project in the realm of human space exploration called the Lunar Gateway. You can see a sort of artist's rendition of it here. And what this is it is a new space station, an upcoming space station that will be constructed in orbit around the moon. And when it's finished being built, it'll actually be the most distant human outpost ever to be constructed. So to give you a sense of just how distant we're talking about here, here we have the Earth, and just 400 kilometers up in low Earth orbit, right now there is the International Space Station, the ISS. Meanwhile, we have more than 1,000 times farther away than that, we have the moon. And the plan would be to put this new space station in a sort of highly elliptical orbit around the moon, like the one that you see here. So I just want to give you a very strong caveat. This is a very old infographic I'm using here, and the configuration and mission profile and elements of the gateway have been continuously in flux for the last 2 years since I joined the project. But it gives you a sense of what the Lunar Gateway is going to be like. It's an international collaboration, just like the ISS, where the partners who are involved, so the European Space Agency, NASA, the Canadian Space Agency, and the Japanese Aerospace Exploration Agency, at a minimum, they would all contribute individual modules or vehicles that all dock together to form the whole thing. Now you can see from this comparison that I'm showing here that unlike the ISS, the Lunar Gateway is going to be quite a bit smaller and more focused in its purpose and activities. So what is definitely still true is that there will be a module called the Power and Propulsion Element, the PPE, and that's the leftmost module here in the sort of stack up that makes the Lunar Gateway. And it's being developed by NASA under contract to Maxar Technologies. It's one of the first modules that's slated to go up in order to kick off the whole process of assembling the gateway in lunar orbit. Last I checked, however, that's going to be no earlier than November 2024. So in addition to that, we have this module here, which is a European Space Agency module for communications and refueling. And then on top of that, there will also be at least 2 pressurized modules that would provide an interior habitat and workspace for human crew members, for astronauts, to live and work all the way out there in cislunar space. So the 2 habitats that are planned right now, one of them is called HALO, H-A-L-O, the Habitation and Logistics Outpost. That's also being produced by NASA under contract to Northrop Grumman. And the second habitat that's being planned is called the IHAB, the International Habitat, which will be provided by the European Space Agency, ESA, under contract to Thales Alenia Aerospace, I believe. Now, again, this is an old infographic, so the concepts for these modules and their designs are already quite a bit farther along than what you see here. So I encourage you to look them up if you want to get a better sense of what they're like. But this gives you, the general idea, like I said before. And then in addition to those sort of semi-permanent modules, from time to time, visiting vehicles or spacecraft could arrive at the gateway, bringing new human crew members and fresh supplies. So the one that I'm showing here, the example is the Orion spacecraft that's under development at NASA. And the basic idea behind Orion is that the human crew members would be able to use this as a spacecraft that they could take out on sort of joyrides, so forays progressively farther and farther out into deep space than humans have ever ventured before, using the gateway as a launching off point. So I think that use case actually highlights what is one of the key purposes of the Lunar Gateway, and it's to give us practice runs, in a sense, for a future deep space exploration mission, such as a human mission to Mars. So the idea behind this is that right now on the ISS, human crew members would be up there for something like 6 months at a time on the International Space Station. And during that time period, they're in near constant communication with Earth. Not only that, but they have fairly regular resupply of water and other provisions. Compare that to something like a human Mars mission, which could take up to, I don't know, something like 4 years round trip, during which time the astronauts would have limited and delayed communication with Earth, and they would have no access to resupply of provisions. So that would have to be a completely self-contained mission. And what the Gateway provides is a stepping stone to that kind of mission profile. Not so much a physical stepping stone to Mars, but as a sort of stepping stone in know-how and technological capacity, a proving ground where we develop the capabilities that we need to survive and operate in deep space, very far away from supply lines to Earth. So, that is the mission profile and experience and capacity that the Gateway facilitates due to its remoteness. But of course, the remoteness of the Gateway poses some challenges of its own, one of which is the fact that the Gateway is only planned to have human crew members on board for something like 1 month out of the whole year. And the rest of the time, it's uncrewed. So the Gateway has to operate by itself and maintain itself. And that's actually where Canada's contribution to the Lunar Gateway as part of the international partnership comes in. So Canada plans to contribute a state-of-the-art new robotics system for the exterior of the Lunar Gateway. So let's take a look at it here. I'm just going to check quickly in the chat to make sure there are no technical difficulties. Now everybody's saying that they're following along. They can hear me. That's good. All right. So Canada's contribution to the Lunar Gateway, which you're looking at here, is known as Canadarm3, and it's actually an entire system or suite of robotic tools. So you can see actually a computer graphics rendition of Canadarm3 on the exterior of the Lunar Gateway here. And there would be a large arm, which has more power and is able to do some of the heavy lifting. And then there would also be a smaller arm, which has more dexterity and is able to do sort of finer scale repair work on the outside of the space station. And then on top of that, there would be a whole suite of special tools and adapters that would go on to the ends of the arms in order to enable them to carry out a wide variety of different tasks. So that makes Canadarm3 the Lunar Gateway's sort of Swiss Army knife and handy repair person all rolled into one, right? You can see a few of the possible uses for Canadarm3 listed here. So the large arm could reach out and grab a visiting spacecraft, capture it and bring it in for docking to the station. Or the large arm could actually even be used for assembly and reconfiguring of the modules of the gateway itself, sort of detaching them and moving them around from one place to another. And then finally, this system can be used to conduct automated repairs and maintenance on the exterior of the space station, particularly when it comes to removing and replacing damaged components like solar arrays, batteries, pump modules. And I would say this is actually one of the really key features and purposes of this robotic system, because what it does is it reduces the need for EVA activity, extravehicular activity, or spacewalks conducted by human astronauts in order to do those repairs. And that's really important because, as you know, spacewalks are expensive and can be dangerous. It's much better if you have a robot operating in what is, let's face it, an unknown and potentially perilous environment, carrying out that work for you. So I hope you can all see this animation when I start playing it. I just wanted to show you Canadarm3 in action. So this is from a concept study that MDA did for the Canadian Space Agency. Here you can see the large arm installing a module on the outside of the space station. Here it is putting a tool back into stowage. And this is one of my favorite operations, actually. This is the arm walking end over end across the outside of the space station. So the tip attaches and becomes the base detaches and becomes the tip. And then once again, the tip will attach and become the base. So this is a double-ended robotic arm that can sort of inchworm its way across the outside of the gateway. So here's the large arm picking up a specialized tool, using it to remove a damaged component from the outside of the space station. Okay, so a key question, of course, is who is going to design and build all of this? There have been significant spoilers in that regard from the topic and abstract of my talk and where I'm coming to you from. So you know that MDA has the contract for Phase A of the Canadarm3, which is the technical requirements definition and the early concept development. And just to give you a sense of how much heritage we have with these kinds of systems, what I'm showing you here is not some computer artistry. It's actually a photograph taken from space, from low Earth orbit, from the International Space Station, showing the two robots that are attached to the exterior of the ISS right now. So we have the Canadarm2, which started operations back in 2001. And then we have Dexter, which started operations back in 2008. And I really don't think it would be an exaggeration to say that without these two robots being in service on the exterior of the ISS, we would not have been able to build the space station, keep it running for the past 20 years, nor would we have been able to use it as a platform for the deployment of satellites and scientific experiments. So these Canadian robotic systems have been absolutely pivotal to the mission of the ISS and to humanity's sustained presence and operations in low Earth orbit. Some of you may already realize this, but because of that, I think we have these two robots featured on the back of our currency. And I think that stands as a real testament to the legacy that Canada has in this kind of expertise for robotics and robotics in space in particular. Now, Canadarm2 and Dexter play a very similar role on the ISS as the large arm and small arm, respectively, of Canadarm3 will play on the Lunar Gateway. The key difference here is the level of autonomy required from those systems. Right now, Canadarm2 is operated by human astronauts, like using a joystick literally to fly the end of the robotic arm around. In contrast with the Lunar Gateway, as I mentioned before, being uncrewed for the vast majority of the time, the robotic systems of Canadarm3 will have to operate and carry out their tasks completely by themselves. So that poses significant challenges to us at MDA in terms of the development of new technologies like machine vision and maybe even a little bit of AI. And I want to just end off and tie this talk all together by emphasizing, driving home the importance of these systems working correctly and autonomously by once again, reiterating and elaborating on what the goals of the Lunar Gateway are. you can see from this little infographic here that the Gateway is a key part of this sort of three-pronged or three-staged approach to solar system exploration that NASA and the international partners have subscribed to, starting with continuing to develop our capabilities in low Earth orbit, especially our commercial capabilities, and then using cislunar space as the proving ground for deep space exploration, like I said before. And then finally, having developed those capacities and capabilities and experience, moving onward to Mars and other solar system exploration, and continuing, of course, robotic exploration of the surface of Mars now in parallel with all of those activities. So that's sort of the approach. And the Lunar Gateway fits in because it's an outpost for doing space science, especially some space science that you can't do as well from a low Earth orbit environment. Anything from astrophysics, heliophysics, the study of the sun, geology and geophysics, particle physics, and of course, space medicine. So studying and understanding the effects of prolonged exposure to a deep space environment on the human body. Then another key goal or purpose of the Lunar Gateway is one I've already alluded to. It's this development of new deep space technological capacity. And obviously the Canadian robotics are key to that effort. The automated in-space docking, the automated assembly and maintenance, all of those things that I referred to before. And then another interesting aspect of the Gateway is its ability to help us perfect the art of the exploration of the surfaces of planetary bodies, because the Gateway will give us a convenient platform from which to deploy missions to the lunar surface, including to the lunar South Pole and the lunar far side, which are of interest for both mineralogy and for prospecting. So mineralogy is more, geology and geophysics and trying to understand the composition of the moon and the history of its formation and what that can tell us about the history of the formation of solar system bodies in general. And then prospecting is prospecting for resources. So same sort of goal of identifying what minerals and chemical elements you're seeing, but with a view towards how those can be harnessed and made use of to facilitate a more permanent human presence on the surface of the moon in the future. And then of course, the Gateway will act as an excellent weather station, helping us to understand what the radiation environment is like very far away from Earth, what the micrometeoroid flux is like, all of these bits of data that we're really going to need in order to make sure that astronauts are safe and comfortable on more longer term, deeper space missions. So hopefully you can all see this video animation playing. I just wanted to end off by showing you another view of these advanced Canadian robotics on the exterior of the space station of the Lunar Gateway. So in the next scene, what you're going to see is a visiting vehicle, a spacecraft on approach to the Gateway. And here is a visual example of some of the operations I was talking about. So the large arm, perhaps detecting the presence of this visiting vehicle, is able to reach out to grapple onto that vehicle. Now, once it has successfully captured it, then it can bring it inward. It could bring it in for docking, but in this case, what you're going to see in the animation is that it's going to bring it in and present it to the small arm. And the small arm is going to retrieve something from the exterior of the craft. Say, for example, a sample container returned from the lunar surface. So the two robots are working in concert here. And the mission lifetime for the Lunar Gateway is something like 15 years. So these are the kinds of systems that you, as future leaders of STEM, could be involved in designing and upgrading and maintaining if you choose to pursue a career in this sector. So that leads me very nicely, I think, to the last thing I wanted to say, which is that here at MDA, we're continuously evolving and we're always looking for bright people to join our mission. So if you're interested in sort of pursuing the next step of your career and potentially joining some of these really exciting and life-changing projects and experiments, then I'd really encourage you to visit this website, the one that you see here at mda.space/careers, and you can see what opportunities we have available right now. We are actively hiring at a pretty prodigious rate. So that's all I have for you today. I really want to thank you for giving me an audience and giving me the chance to tell you my story and to explain what kinds of things I've been working on in the last 2 to 3 years of my career in space sciences and technology. I've thrown up some contact information there if you'd like to get in touch with me with any further questions beyond what we cover at the session. But thank you very much. I really look forward to all of your questions.
Hi, so thank you for the amazing talk, Jamil. That was incredible. It's so exciting to see the work that you're doing on the Lunar Gateway. And I'm going to take it right to questions from the audience. So if you're still mulling over your questions and you haven't put them in the chat yet, feel free to. I'll start us off with a question from Andrew Higgins. Can you comment more on the radiation environment that astronauts would be exposed to on the Gateway, particularly galactic cosmic rays and solar events, CMEs in brackets?
Yeah, so that's a great question. I think it's digging into what is still a relative unknown. So the first couple of modules that are going to go up on the Lunar Gateway, particularly the HALO module, will include a couple of weather stations, one of which is called, I believe it's called Hermes. But the idea behind it is that those are experiments that would be able to measure cosmic ray flux and as well as ionizing radiation from the sun and from other sources. So I think this is an example of an area of active research. So I can't give you a quantitative answer to your question, but I think it's something that is a considerable concern because you're not within the protective sphere of Earth's and its magnetosphere and all that. So we really need to understand what the radiation environment is like out there at those distances better.
And then our next question from Martina Trusch is, do you know how many astronauts we plan on having at the Gateway at a time?
No, I don't know the crew complement. I think it's going to be a fairly small handful of people. And I think that, it's going to be, just a handful of astronauts. So probably fewer than even the maximum complement of the ISS, given the lower habitable volume that the Gateway will have.
And kind of in a related vein from Aya, she wants to know, why are we only staffing it for 1 month per year? Is there an initiative to try for longer periods?
Right. Well, I think that part of it is just the logistics required in getting human crew members out to those distances. It's considerably more, expensive and resource intensive than low Earth orbit. So I think the approach that's being taken by the Gateway is a stepwise approach of having humans living and working there only for a few months at a time. And then those unknowns that I alluded to before, are also things that we need to gather more data on. So it does seem like a safer and more risk-averse approach to me to have people living and working there for shorter periods of time at first. And then as I mentioned before, the Gateway mission lifetime is 15 years. And I doubt very much that we're going to be in that same sort of holding pattern for that entire period. That what's planned to start is 1 month out of the year.
Oh, that's amazing. And I have another question here. Are there collaborations with university laboratories? And if so, are there any specific university labs which are working on the Gateway in Canadarm3?
So I know that academic research laboratories are involved in those two scientific instruments that I mentioned that are going up on HALO. And I also know that in 2018, there was a Gateway science workshop that was held that solicited feedback from the academic community on what types of science the Gateway could be used for, and that NASA and the other partners have sort of collated all of that data. So so two parts of my response to that question. One is, yes, there are specific labs. I believe it might be JPL and others involved in the currently planned science instruments, and then there's the potential for future instruments to go up that university research labs would have a hand in developing. So it's a bit open right now.
Someone said in the chat that they're still emotionally recovering from seeing the robot walk end over end, and I have to agree, it's pretty amazing. Yeah. I think that's really, we can do so much in space with robotics, even if we don't have crews there. Is there something that you're especially, you mentioned you love the maneuver where it walks end over end. As a question for me, what tool manipulation or what aspects of the new Canadarm3 are you most excited about?
Yeah, that's a great question. I wanted to mention that the walking end over end is a capability that Canadarm2 has right now, but as I said, it's not a fully automated process. And then the first animation I showed was quite a bit sped up. The fancier animation at the end with better graphics gave a better sense of the tip rates, where for safety and to minimize the loads that the arm has to bear, the tip is only probably going to be moving at centimeters per second. So the sort of lightning fast whipping across the outside of the station is a bit of artistic license. But I actually think I really like the idea of just the machine vision capability that would be required in order for the arm to be able to detect its orientation relative to a fixture on some external vehicle, align itself to it, and then move in for capture. Because right now, that's the kind of operation that takes place with a human in the loop. So a human as part of the control system to visually evaluate what the alignment is to some sort of standardized vision target, right? And now the robot is going to have to be able to see and understand that vision target and what it tells it about its orientation in all 6 degrees of freedom relative to the vehicle that is trying to capture. So for me, that's a really exciting and challenging capability of the new robotics.
Wow, that is incredible. This robot needs to be an athlete, basically. So we have a question from Arjun. Excellent presentation. I was wondering if MDA is offering student internships right now. If so, would a second-year engineering student be eligible to apply?
Yeah, the generic answer is yes. I can't speak to right now. But yeah, yes, we do offer student internships quite frequently. I've worked with student interns, and including as early as second year. So definitely, like I said before, go to mda.space/careers, and you can actually sort the open opportunities by what type of position they are, whether they're for a student intern or a junior engineer or an intermediate or regular or senior. So you should be able to see on there what qualifications they're looking for. So, yeah.
Thanks. And kind of as a follow-up to that, as someone who's worked with a lot of student interns, what do you look for in your interns? What are you hoping to see in people who want to build the skills now to hopefully have a future career in the space industry or at MDA?
Yeah, I would just say that the willingness and ability to learn, because it's great. The student interns who come to us, they're always very bright and they're always excelling in the technical content of their courses. What is difficult is the soft skills of adjusting to any particular organizational structure that in any particular organization that you've begun working in, and understanding what our processes and methodologies are, and then being able to adapt yourself to them. So there's a lot of on-the-job training that happens, especially even when you're coming on board as a full-time staff member, but especially if you're a student intern. So that's not to say that we don't want employees to suggest new processes and procedures and new ways of doing things. We love to see that keen initiative and new ideas, but we also like the ability to pick things up in terms of how things are done and what our processes are. So that's what I would look for, I think.
Thank you. Now we have a question from one of our staff members, Maya. She is currently in her last year of high school, and she asks, as an aspiring astrophysicist, what was your journey like to become one?
Cool. Thanks for the question, Maya. It was circuitous and nonlinear, right? I have been interested in astronomy and physics since I was 4. But when I was 18, it wasn't clear to me that I necessarily wanted to go into a pure science degree or what that would entail. And so I ended up enrolling in engineering physics, which kind of seemed like the best of both worlds because it gave practical skills in hardware and software development, but it also gave that broader background in physics and mathematics that would enable one to either pivot into a pure science career or become an applied science researcher developing new technologies, right? And then what happened was my co-op experience as an undergrad ended up being a critical, critical to my development of my career because I ended up working at a couple of different research labs. The first one was the Sudbury Neutrino Observatory, which was a particle physics lab 2 kilometers underground in sort of northern Ontario. And the second one was at an astronomical instrumentation group at a university in Alberta that actually develops new cameras and new spectrographs and new instruments that upgrade existing professional observatories, some of them ground-based, like in Hawaii and Chile, and some of them space-based. And that was where I discovered a new niche that I didn't know existed. Sort of the third prong to astrophysics. There's observation, there's theory, but then there's development of instrumentation, development of the new hardware that enables new scientific discoveries. So when you're just starting your undergrad, you don't even know what exists and what's out there. And those internships and the co-op experiences really help you grow and understand where a niche might be. Maybe you want to apply your passion for physics to medical physics and medical imaging, and you didn't think that was an option before, right? So I would just encourage you to let that path take you wherever it goes, because there's a bit of a random element to it. Explore what opportunities are out there, and you may be surprised where you end up and where a career in STEM takes you.
Well, thank you. So now we have a question from Kashfi, more on the imagining the future side of things. Mm-hmm. How long do you think it will be until there's a Mars space station?
That is very hard to predict. I think right now, like, people who are attending this conference are engaged with dialogue about space exploration. So you probably know that the gateway and the multi-pronged approach is controversial. And some people might say, why don't we just go directly to Mars? Why don't we just go directly to exploring, other moons in the solar system to search for resources, to search for signs of life, right? And what's happening here is, I think, is a cautious, stepwise approach of developing, like I said, those capacities and capabilities. So Gateway is going to take us from the mid-2020s all the way into the following decade. And then I would imagine that, even just the first human Mars mission wouldn't take place until that following decade. I'm just trying to extrapolate in my brain right now. So you're looking at the 2030s. And then, the technological development that would be needed to have permanent infrastructure all the way out there. It's hard for me to even predict, how long it would take for that to fall into place in our lifetime, I think, but decades out would be my guess. Yeah.
That sounds like it. It's almost like imagining science fiction, but we are living in those times. If I told myself when I was a kid that we'd have a moon space station, that just seems, the ISS at that time was so wild. So then now we're doing it around the moon. Why not Mars next?
Yeah.
We're almost at the end. So if anyone has some last minute questions, feel free to leave them in the chat. I wanted to ask you about your day-to-day, Dr. Shariff. What does a typical day look like for you?
Yeah, so I recently made a transition from working on fully on Canadarm3 to taking on sort of smaller projects that MDA works on, including some of the space science instrumentation that we work on for Mars rovers and other such things. So, the answer to the question has changed recently, but back when I was working on Canadarm3, it was very much sort of the bread and butter systems engineering, where we were taking the mission requirements as passed down to us from the customer, in our case, Canadian Space Agency, and trying to decompose those into specific quantitative technical system requirements for the arms and for the interfaces to the arms. And so that's a lot of design work and documentation day to day. So because Canadarm3 is not in the phase of manufacturing and assembly yet, it's not like I was spending my days in the lab. I was essentially working on a lot of technical documentation that would ensure that the system that we eventually develop will be able to meet the needs of the mission and of the program. So that's kind of what my day-to-day was like up until very recently, I would say. Yeah.
Oh, that's exciting to hear. I find systems engineering work really interesting, and it's not something that's always taught really well at the undergrad level. How to define robust requirements, and so much work and research goes into that, because if you don't have good requirements, the system at the end of the day won't be the system you need.
Yeah. And I would say that when I was an academic, we were doing that informally. We just didn't realize we were doing it because we were our own customers. So we defined the science requirements for the spider telescopes, and then we had to figure out what the technical performance requirements would be for a system that we were going to then design and build to do that science, right? So it was weird because I was like, we were sort of every stakeholder at once and participated in a microcosm of a gateway-like mission from end to end, right? So I think that was really valuable to be at both ends of it.
Do you have any resources you'd suggest for someone like me who is interested in systems engineering, like where to get started learning about the skills you need?
Yeah, so off the top of my head, I know that NASA has a systems engineering handbook that's specific to kind of space type projects. Yeah. That gives you a sense of just how the missions are phased and what design reviews and things happen at various stages. And then I think there's a systems engineering standards body organization called INCHOSE, INCHOSE. So they may also have some resources that are more generic to systems engineering beyond just the space sector.
Oh, thank you. So to close it off, I'm going to ask one more question from the audience. Aya asks, we have two questions. We'll see if we get time for both of them. So Aya asks, I believe you mentioned MDA was handling the technical specification definitions. How far along in the process of designing Canadarm3 are you at this point?
Yeah, so it sort of depends on which contract you're talking about. And I know that it is public domain knowledge that there are two contracts. There's one that started a little bit earlier to develop the interfaces to the arms so that international partners would have a standardized interface control document that tells them how to make their spacecraft and vehicles compatible with Canadarm3. And that contract started earlier and is sort of in the second phase B, where you're in preliminary design and you've gone past the requirements, whereas the contract for the arms themselves and the robotic systems themselves is still in the requirements phase. So that's what I can tell you. So the first contract is a little bit ahead just because we need to design the interfaces to the arms, since they would be, according to the putative gateway schedule right now, they'd be going up a little bit earlier than the arms themselves on various international partner vehicles, right? So that's kind of how that was structured.
Amazing. And so last question from the audience, Yusufa asks, along the lines of MDA has this incredible legacy in the field of space robotics and really is a pioneer. But now there are so many new private space companies. How do you navigate that, having this established legacy, but also being innovative to keep up with everything new happening in the space industry?
Yeah, I think that's something that's really actively in the minds of MDA at the higher corporate levels. We aren't just into robotics. Robotics are primarily our Toronto, Greater Toronto Area office focus, but we have the Montreal office focused on satellite systems, which is a big area of development in sort of the new space paradigm, right? And the Richmond, BC office focused on informatics and geo observation, right? And more on the data analysis and big data side of things. So I think the fact that we've sort of, and even in Brampton, Ontario, we do medical robotics and some nuclear programs. So the fact that we've diversified a little bit means that we're sort of actively looking at how to incorporate new space and um, processes and agility into our future business ventures, if that makes sense.
Yeah, that makes sense. You have so many things going on.
Yeah.
So I want to thank you so much, Jamil, for being here with us today, sharing your incredible wealth of knowledge and inspiring us all. We're going to head back to the main stage now to hear from Steve Mathieu on developing a commercial spaceport in maritime Canada. Thank you so much.
Thank you very, very much, everyone. It was a pleasure to be here.